Hi there again. This is the third of three proofs required for Leaving Cert Applied Maths Moments of Inertia questions. The final one is the disk of mass m and radius r. So we have here a disk of mass m and a radius r, and we're focusing in here on a circular hoop element of mass gm, a small width gx, and its circumference of 2 pi x. So effectively this distance from here to the circular element is x, and the circumference will be 2 pi x. So as with the example on the square lamina, we have a density area function where mu is the mass of the disk divided by the area of the full disk, which is pi r squared. The mass of that small circular element, gm, is the density times the circumference of that circular element times its small width. So effectively, it's mu times the circumference times that small width. The moment of inertia is given by the sum of the product of those mass elements times the square of the distance from the center of the disk in this case. So I'm replacing gm by 2 mu pi x, and combining with that x squared there gives me a moments of inertia function of the sum of 2 mu pi x cubed dx, combining that x with that x squared there. So when we integrate, it's different to the two previous examples that it's not from minus r to plus r, but from the center 0 to r. So just note that the limits are different when dealing with this moment type of this proof. So we integrate x cubed this time and get x to the 4 over 4. These are constants as regards the integration. And applying the limits 0 and r, we get r to the 4 over 4 minus 0. Just returning mu to m over pi r squared, combining with 2 pi, we get 2m over r squared. This leaves us with r to the 4 over 4, leaving us with our final answer of 1/2 m r squared. So I suppose the most challenging portion is this bit here to get the initial sort of area of that circular element there, and once you get that started, you have a slightly different integral, and it's somewhat easier to evaluate in fact, but the final answer is 1/2 m r squared. So those three proofs have now been presented to you. They are given 20 marks in every moments of inertia question, leaving the problem part only 30 marks. Thank you.